Hi, thanks for joining me. Today I've got a graph theory slash combinatorics video for you. Here I've drawn a flower and it's definitely not very artistic or advanced, but it's a flower nonetheless, and we want to know in how many ways can we draw this flower. Now technically the answer is infinitely many, but I want to make it a bit more rigorous, or a bit more clear what I mean by draw, so we can get it down to a finite number. Well, we've got here a vertex, here a vertex, and here a vertex, so you can think of this as a graph, and these guys here are edges, like so. And we want to know, well, how many ways can we draw this sort of without taking our pen off the paper, and so that we never sort of repeat a loop or repeat an edge or anything like that. So we can't go up here and then back down here, because otherwise we could just do that infinitely many times. So we're not supposed to repeat an edge, and we want to know in how many ways can we draw this. Hopefully I've explained the problem well, but if you do want to have a go at it, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so I've just put my drawing of the flower on that side of the board so I can do some workings on the left hand side of the board. The first thing I want to do is consider the degrees of each of these vertices here. So the degree of this vertex here is just 1, because there's clearly just one edge coming out of it. The degree of this vertex here, well, I'm going to consider these loops, sort of these petals, to be 2, or sort of constituting 2 towards the degree. So this has 1, 2, 3, 4, 5, 6. So this has degree 6. And this vertex here has degree 1, 2, 3, 4, 5, 6, 7, 8, 9. Like so. Now, to draw this flower, we must start and end at a vertex. And now I claim that we must start and end at these two vertices. So either start here and end here, or start here and end here. And the reason for that is we've got to consider the intermediate vertices. Any intermediate vertex in our path of drawing this flower must have even degree. And the reason for that is, you can think about this like, for any intermediate vertex, you must come into that vertex and then come out again. So this vertex here, you must come into and then come out. And that means it must have even degree, because every time you come in, you come out. So for every edge coming in, there's a corresponding edge coming out, which means that the degree of that vertex must be even. And the only way we can have that is by starting and ending at these two vertices. So the intermediate vertex, this one here, is even, 6. It's the only even number out of these 3 here. Okay, so we must start and end at these two. And also notice that if we start here and have some path to draw this flower, then if we kind of reverse that path, that corresponds to a path starting from here and ending here. So we can assume without loss of generality that we start our path here and end up here, and then the number of ways we can do that, if you multiply that by 2, that will give us our final answer. So we can start off here, and then we're forced to just go up, so that there's no choice in that. But now we get to these 2 petals here, and now notice we must do these, because if we go up this edge here, we can't then come back down to do these petals, so we must colour these petals in first. Now there are 2 different petals, so there's 2 factorial ways of choosing which petal, the order of the petals. So we may do this petal first and then this one, or we could do this one first and then this one. So 2 factorial is just 2. But then notice that for each petal we've got 2 different ways of drawing them, because we could go this way for this petal, or we could go this way to draw this petal. And the same for this guy here. We could go this way, or we could go this way. So there's 2 ways of drawing this petal and 2 ways of drawing that one. So we've got to multiply that by 2 squared, like so. So that gives us a number of combinations of ways of drawing up to this bit. Once we've done that, we're forced to go up this stem here, and we get to that vertex. So that doesn't, we're forced to do that. There's no choice in that. And now we've got 4 petals to kind of draw in. But each of these petals here, the same argument holds. We had 2 ways of choosing the petals here, the 2 factorial ways, with the 4 factorial ways of choosing the petals here. So we multiply this by 4 factorial, like so. So that will give us the way in which we can order the petals. But then again, for each petal, there are 2 ways of drawing it. We can either go this way, or we can go this way, or this way, this way, or this way, this way, or this way. So we've got to multiply this by 2 to the 4, like so. So we've got 2 factorial times 2 squared times 4 factorial times 2 to the 4, and that will mean we end up at that vertex and we've drawn in our flower. But then, as I said at the start, we've got to multiply this whole thing by 2 to correspond to the reverse path, so starting from this vertex and ending at this vertex. Now if you multiply this all out, you get the answer 6,144, and that is our final answer. So the number of ways of drawing this flower is 6,144. So a lot more than I expected when I first saw this, but the argument holds and we get this final answer. I hope you have enjoyed this video. I don't have too many combinatorics videos on the channel, so if you want to see some more, let me know in the comments. Anyway, thank you for watching. I'll catch you in the next one. Have a great day.